In this lesson, we're going to learn how to distinguish between organic and inorganic compounds. We're going to describe the features of alkane structures, and we're going to learn the difference between an alkane and a cycloalkane. When we look at our definition of molecular compounds, we see that they contain two or more nonmetals. We can further subdivide this into organic compounds and inorganic compounds. So organic compounds are composed primarily of carbon and hydrogen, although we will soon see that they can have some other elements in there, but the majority of the atoms are carbon and hydrogen. When we look at inorganic compounds, we see that these are primarily not carbon and hydrogen, but they are still non-metals. Let's dig a little deeper into organic compounds. So the first thing we see is that they're primarily composed of carbon and hydrogen, and this is why these are typically known as hydrocarbons. So we get our hydro for the hydrogen and then carbon for the carbon. We see that they may contain other elements. The most common among these are oxygen, nitrogen, sulfur, or the halogens. The halogens are everything in group 17 of the periodic table, including fluorine, chlorine, bromine, and iodine. Let's look at an example of methane, which has the formula CH4. This is the simplest hydrocarbon that exists because it has a single carbon atom, and we can't have less than that and still have an organic compound. A key thing to note is that when we have a carbon atom, it must have 4 bonds. We will look more later at the types of bonds it can have, but the important thing to remember now is that each carbon must have 4 bonds. In this case, each of those bonds is to a hydrogen atom, so we have 1 carbon and 4 hydrogens to form CH4, and this is the simplest hydrocarbon that exists. So after looking at methane, which had 1 carbon, we can also see molecules that have 2 carbons or 3 or 4 or 5 or any number of carbons. And so they form some kind of a chain of carbon atoms, and they can be connected to one another in different ways, but it's just mainly carbon atoms. And we know that the bond between any pair of carbon atoms are all single bonds. We still have to follow our rule that every carbon must have 4 bonds, so we have enough hydrogen atoms so that every carbon has 4 bonds. When we have this basic structure, these are known as alkanes. So anytime we see the suffix ane, what it's telling us is that we have carbon-carbon single bonds throughout the molecule. Cycloalkanes are very similar to alkanes. The difference is that they form a ring. Cyclo means going in a circle, so we have a ring of carbon atoms. We see that it has the ane suffix, so that tells us we still have carbon-carbon single bonds. We also know that we have to have enough hydrogen atoms so that every carbon has 4 bonds. So we have our ring for each of those, all single bonds, and enough hydrogens to form 4 bonds.